Hello students. Last section we saw the components of your computer. Okay, and a small digital system. This is your any digital system having this components, and we'll saw one by one as this section. In this section, we'll see the computer instructions. Okay, what is computer instructions? What is instructions? Simply, instruction means a command to do something. Okay, if you in human, if you say something to say take a command to do go out of from the class means it's a command, or read something, it's a command. Something like computer instructions means a command to a computer to do something. Instruction have computer instruction have three ports. Okay, that is mode, opcode, and the addresses. For example, I say a plus b, add a comma b means what add the value of b to a, and the resultant should be stored, or next line I have to say store sum equal to add a comma b. Whatever be some addition is going on, the addition should be stored in something like. So here we call as a because we are reading here microprocessor 064096 microprocessor. Sorry, microprocessor have this memory, that is this type of memory. Here we are using the opcode for instructions. Opcode means mostly add, subtract, a little bit of English. That is called your operator. It's not completely addition, subtraction. Just it will say add or sub something like that is called your we say opcode. And this is address from the memory to memory to register to memory to IO to register. Many types of instructions are there. So we'll see one by one. But this is the general format of any instruction. The instruction means you should be this. This is the syntax of your instructions. Computer instruction are set of machine language instruct that the particular processor understand and execute. The computer perform tasks on a basis of the instruction provided. So it's a simple task to any if you task the instruction. If you perform any task, you should give in instruction format. Okay, there are three types of your instructions. That is memory reference instructions, register reference instructions, and IO input output instructions. That is I already told you the operand the opcode maybe is a specific. It is differ from microprocessor to processor. Okay, any digital system to digital system it will differ, but the address should be same. Maybe not same. Maybe it's the format is the same. The address should be from memory to transfer from memory to memory. If you want to transfer data from memory to memory or memory to register or some calculation. So this is the common to other digital system also. But the opcode should be differ, maybe differ. So opcode and address. Here, whenever say address, it is referred to memory. Whenever I say register, it is register instruction. IO means IO input output instruction. There are three types of instruction can be used to do some task. Okay, this is a table, general table. I already told you these are assembly language programming code or opcodes used in your to do some perform a task, addition, multiplication, division. For example, you say A and D. This is the address. Okay, this is your A and D is a symbol or we say opcode. This is and memory word to AC. We have to add the word total space, the total byte to a accumulator, that is AC. The result should be stored in accumulator. Add is simply add. Add means is a general add to, and the result should be stored in accumulator. Accumulator is a register. So this is the opcode. These all the opcode. See one by one. Read the meaning here. Okay, this and here see clear means clear AC. Accumulator should be 0, initialized to 0. CLE clear E like this. We can register. We can clear all registers. Actually, any computer digital system have registers. Some registers. I will say here. Next we will see the registers. Okay, how many registers are there? So this is we call as the opcode. Okay, that is if you write the addition of two number or multiplication of two number, Using this code, we can use addition of a number, multiplication of a number, division of a number, anything. Okay, using this code, our code cannot be work. Instead of add, I'm say adding means not working. It's not work. So the opcode is there. What are the opcodes are there? We should use for any instructions. Okay. Come to the computer register. Actually, there are 1, 2, 3, 4, 5, 6, 7, 8 registers are there in your process, any processor, in the processor mostly. It may differ, processor to processor, it may differ. Register are type of computer memory used to quickly accept, store, and transfer data from instruction that is being used immediately by the CPU. Hence, the processor is very fast. Okay. Also, the CPU is very fast to bear or to compare. If you use secondary storage, hard disk, disk, magnetic disk, not going to work. So for this, the registers are used for any calculation, for transferring data, something like. So there are the DR means data register, AR means address register, AC means accumulator, IR means a small memory size. Actually, it's a simple memory size that is going to use for transferring, for calculating, for doing some swapping, anything. This register will be going to use. Okay, this is a general format. This is PC. This is registers type, the size of your PC, AR, TR, something like. These are your memory unit, memory, and this is your other register. Also, the general, there is basic register and a basic computer register and the memory. The total is called as the registers. It is using in the computer. Also, you see this is a whole connected. All registers are connected. How it will work? This is your diagram, block diagram of your register. How it will going to work? How the transfer is going on? Okay, this is a block diagram of your registers. Instruction set completeness means the instruction should be complete, not be incomplete. If it is complete, then only it will work. Okay. So we will see later the other things also. Here I'm going the main things. That is the main here is you have a control unit and basic computer. That is the main control, the block diagram of your control unit and the basic computer. This is a simple computer. It have a block diagram. Okay, here everything is written. Okay, what are the things are there? What are the control is there? Where you read all those things one by one. Due to the time limitation, I finished fast. So here you see this instruction completeness means you have the instruction should be completed. Timing and control timing for any instructions. Okay, for any instructions, the timing should be, signal should be there, timing and controlling. Timing and control all sequential circuit in the basic computer CPU are driven by the master clock, which is expected of ANR registers. So for any calculation, for any instruction transfer or arithmetic logic unit or any instruction, the timing should be used. Within timing, the control is going in. Design of your control unit. The control unit is classified into major categories. That is hardware, microprogram, control, and timing signal. We'll see one by one later. Okay. Till this is a general diagram of your control unit. For this, we'll see later one by one detail. This is a general diagram of your basic computer. Okay.